name is Zubin. I'm the co-founder and CEO of Think7. Think7 is an industrial IoT stroke industry 4.0 solution provider. Uh, uh, Standing here before you all as a solution provider, I come with the background of wearing the hat of an SME manufacturer as well. So I've spent more number of years in manufacturing than I have in digitization. So I will try and share my experiences, keeping both these points of views. Uh, so I have spent 25 years or 23 years in sheet metal component manufacturing, primarily for the auto component industry. We were supplying to tier one manufacturers like Bosch, Borg Warner, Magna, Brakes India, Ricoh Auto, and others. And a pain point that I had experienced at my factory back in 2012 during a customer audit got me to think, why don't we bring in some amount of paperless operations into our factory? The observation from our customer during their audit was with regards to work instructions that are normally displayed for the operators and the inspectors. And what had happened in that case was that the documents displayed on a particular machine, work center, were not of the job that was running, as is the case, I believe, would be in a lot of other factories. It was a minor NC, but a visit to the same customer's factory a few months later when we were getting our development components approved, and I witnessed the same thing, except in a larger setting, air-conditioned factories, their CNC machines had different documents compared to what was actually being produced. And taking that conversation further, I felt, why don't we try and get the right instruction to the right person at the right time. Basically, get that paper out and get a digital tablet or a device in. From there, we grew into a full-fledged IoT and Industry 4 solution where we connect machines, make factories paperless, and also bring in a lot of analytics in the quality, traceability, and OEE domains. So with that, I will quickly walk you through. I'm going to try and not bring in too much theory. The idea, I want to take these 20 minutes that I have and share two case studies. The idea of sharing these particular case studies is to plant the seed of thought that digitization, Industry 4, 5, 6, whatever we talk, keeping all these terminologies aside, how do we look at the problems that we face in our factories and figure out simple ways to solve them and drive improvements? Basic thing, we need better profits. Customers are not going to pay better prices. So the only way to get higher profits is to then therefore reduce cost. A lot of speakers talked about cybersecurity. We talked about SDG goals. We talked about sustainable practices and all of that. If at the end of the day, if you have 10 machines in your factory and you're producing 10,000 parts a month, and with any technology, you're able to produce 11,000 parts from the same factory, you are going in the sustainable direction. You have reduced your energy consumption because the same energy is now giving you more output. Your waste, your same water and other effluents are giving you the same output. You're just getting more from less. So it need not be terminology heavy, technology heavy. It could be very simple things, and that's what I want to do. Quick thing, what do we, a quick introduction, I've already given you, but some more. We've come out with a plug-and-play solution. Again, it has to be easy to implement, quick to implement, otherwise teams get bored. No one's going to spend 9 months and 12 months trying to implement a project. Everyone wants to see benefits come in very quickly. So we have a very simple plug-and-play module that we can come in with, train your team, and you can get going. We target SMEs, particularly discrete manufacturing space. So if you are in auto components or packing products, rubber, plastics, etc., that's who we target. Our mission is to digitize the backbone of Indian manufacturing. We are becoming the factory of the world. So we have to become more competitive and attract attention, not just from a cost perspective, but also from systems and consistency. So our customers are expecting us to deliver consistently good products day after day, month after month, year after year. Are our systems in line for us to be able to do that? Depending on people, depending on manpower, to get this done is always a challenge. With that, I would like to share, a few thoughts, or I want to trigger some thoughts or relate to you in a few ways before I get into the two case studies that I want to share. Imagine your factories, or rather your factories, don't have to imagine that. Imagine having a banana after lunch every day, chopping that banana in half and tossing half of it into the bin and eating only half of it. Does that make sense? That every time you have a fruit or anything you have, you throw half and you consume only half. It doesn't make sense. But that's typically what's happening in most factories. We have the machines, we have the people, we have the material, we have the power, but for different reasons, right? Whether it's lack of tools, whether it's lack of planning, whether it's lack of components, maybe a fastener, we are not able to run our production, and we stop, maybe for major reasons, but maybe for minor reasons as well, right? It could be that discipline of manpower clocking in is not there. They come in 5 minutes late every shift, or maybe every time they take a break. Now imagine if you have 20 machines and you're losing 5 minutes twice a day on each machine. That's a lot of time that is being lost. So that's what we're basically doing. We're buying our fruits, we're buying our vegetables, and we're throwing half of them away, whereas they're perfectly good for consumption. So if that's a problem, then those problems can be solved. The other thing is our quality. How confident are we of the quality that we are turning out, right? We do a lot of audits. We get third parties to audit us. Our customers come and audit us. But a lot of our quality systems are paper-based and Excel-based. Revisions on the drawing very rarely find their way to the shop floor. And even if they do, 6 months later, you've got different versions of the documents floating around, becomes a challenge. Inspections that have to happen every hour sometimes don't. If you're producing a part with a critical dimension, with a very tight tolerance, are you certain that the person who had to inspect the part did so, checked it as per the latest drawing standards, and only then allowed your production to take place? So rather than quality by chance, if you digitize your factories, you can actually go to quality by choice and therefore proper quality control. And finally, traceability. A lot of work that we do is on paper, is recorded on paper. You've got your production records, your logbooks, your quality documentation, your supplier certifications, etc. It's all on paper. It's great, except when you have to retrieve it. If your customer has a failure, if your product supplied to your customer fails, are you able to identify which machine, who was the operator, who was the supplier, what were the machine settings, tool settings, everything? Maybe you will be able to, but that will be in disparate sheets of paper, different files in different systems, and you'll have to manually retrieve them and correlate them. But by digitizing your operations, you will be able to do this with the click of a button. One of the very critical case studies that has happened a few years ago, about 7 or 8 years ago, was this case with a seatbelt and airbag manufacturer in Japan, right? They have since then had to break up that factory. It was a large company, one of the top 2 or 3 in the active passenger safety product space. But their airbags has an inflator, which is a sensor that explodes to inflate the airbag based on certain inputs to the sensor. What was happening with one of their suppliers' inflators was that it would explode while the car was in motion without an accident having taken place. Certain speed and some vibration would give a wrong signal to the inflator to explode, leading to the airbag to inflate, causing an accident, injuring the drivers and passengers, where the function of that airbag was to do the very opposite, was to save the drivers and passengers and prevent accidents. When their customers, and that included the who's who of the auto world, like GM and Ford and Nissan and Toyota, and all of them who were their customers, asked for traceability records and a root cause analysis, they arrived at the root cause where they found that one of their suppliers' inflators was defective. But what they did not have was which airbags did those inflators get fitted into. So the recall that took place was for every airbag that that factory produced over a long period of time. And that basically killed that company, and they have had to since sell parts to different factories to different of their competitors. Traceability 7-8 years ago in mature markets like the US and Europe was mandatory by law. In India, it is going to be mandatory by law very soon. In certain things, in food and pharma, traceability is already a statutory requirement, but that's coming into other spaces as well, where consumers are impacted. So if your factories are still running and if your documentation is still on paper records, now is probably a good time to start looking at how do you want to digitize this so that you can limit your liability and also prevent defects from reaching your customers. So you actively prevent those defects, but you also, in case of any defects, are able to limit your liabilities to just the defective products. So insurance, traceability is today not just something nice to have. It's basically insurance for your very business, for everything that you get up every morning for. So I want to come to two case studies. And the reason I want to highlight these case studies is they are actually diametrically different in nature. One of them, the first one, we're going to talk about improvements in cycle time to the tune of milliseconds. And I'll share with you, my excitement when we worked on this project, but also my confusion about why the customer wanted to look at milliseconds in cycle time. The other case study is, diametrically opposite, not so accurate in terms of times and, technology, but a very simple problem that a lot of us, especially in cities like Bangalore, face day to day in our factories, and how it can actually impact negatively your profitability, and therefore bringing in visibility, how it can improve your bottom lines. So we had a client manufacturing engine parts. These were pistons and piston rings. For this particular project, it was the piston that was being machined. So they had a line, a fully automated line, where the only manpower required was at the entry to load the pistons into a cassette, to feed it into the line, and after that, the robos took over, the pick-and-place systems, etc. So they thought, when they set up that line, that it's all automated and they have hit the peak of efficiency that they can drive from this line. We got into that project from a traceability point of view. As the client started reviewing their reports and documentations of cycle times and downtimes and quality of that particular line, we get a call one day from the customer saying, our cycle time reports are being recorded in seconds. Are you able to give us in 0.1 seconds, so 100 milliseconds? So from a technology and a software point of view, when you're talking digital, you can go to any least count, right? It's not dependent on a stop clock or a stopwatch on your phone or an app on your phone. Because we are looking at digital signals from the machine, every time the part is clamped, unclamped, motor starts, motor stops, we are actually monitoring in milliseconds, but reporting in seconds, because no one thought that less than 1 second would be that critical. So we made some changes to the software, and we went down from 1 second to 100 milliseconds in accuracy. Few days later, they said, okay, we want 2 decimal places. So we made the quick change again. That's when I asked the customer, why are you measuring 10 milliseconds? What's 10 milliseconds for you? You cannot possibly make money in 10 milliseconds, right? Maybe you're going after the wrong project. So he said, listen, for you, is it a problem to give me these 10 milliseconds accuracy? I said, not a problem for us. So we gave it to him. Few months later, when we went back to talk to them and find out what they did, we found, and they told us, that they reduced their non-value added time, that's the loading and unloading time of the robo, from 9.25 seconds to 9.1 seconds. Just by analyzing in milliseconds where they lie, they moved the pick point of that part a little closer to the machine so that when the cycle ended and the robo removed the part, put the part and came out, they shaved off 150 milliseconds only. But because it was robo-controlled, it's also consistent throughout the day. But that 150 milliseconds resulted in 158 extra parts from that line per day. And that is not a small number. When you talk 150 milliseconds, you may wonder where's the money in that. But now when you're saying, I produce, I think 2,500 parts a day on that line, and now I can make 158 parts more on the same line with the same robos, the same electricity, the same operators, and the same space, that 150 parts is pure profit. But this is the value that digitization can unlock. It can help you see things that are otherwise not visible, right? So it need not be something extremely complicated. It need not be something on a very large scale. This line had 7 or 8 machines only, but they got a return, removing material cost, of course, for those 158 parts, of nearly 30 lakhs per year just by investing about 6 or 7 lakhs. So that's money that is actually lying around, and that is what digital technologies and digital tools can help. What I always say is, software will not run your factories, right? You and your team and your people will have to run your factories. But what software will do is it will give you a torchlight and shine the light on the gold dust that is floating around in the air in your factories. Today, you can't see that gold dust, but if you are able to do it and capture it, that gold is available for you to enjoy. Now, a diametrically opposite use case. There we talked about 150 milliseconds, fully automated lines. There were robos. We got down into very high accuracy monitoring. We had another client who was based in Rajaji Nagar here, and they had a unit in Hosur, just in Bangalore, just before the border, so Atibele sides, and they were supplying to commercial vehicles, sheet metal and fabricated components. So the management was sitting at their main plant in Rajaji Nagar. We did the project at their newer factory on Hosur Road, Atibele, close to Atibele. And we just digitized their factories. They also didn't know what they wanted out of it. They said, once we connect, we'll get the data. We will see what we can derive from that data. What they found, and this is very simple, and a lot of people, and I purposely highlight this use case because it has nothing to do with digital technology and machine connectivity and Industry 4. What they found was that their machines were stopping for about 3 to 5 minutes, twice, thrice, 4 times a day, at the same time. And that was because power was failing, their auto changeover for the DG was not working, so someone would run across the yard, switch on the DG, do the changeover, and come back. And this, being Bangalore, was twice or thrice a day. And every time that person had to go and switch it on, sync up the frequency, and come back, 3-4 minutes on around 30 machines. So you're talking about 120 machine minutes each instance. So they didn't know that this was happening. Now, when they are looking at a daily report which was generated on paper and submitted to them over email, and they're looking at yesterday's information, they know that the machine stopped for 3 minutes. But what the software was able to do was tell them that the machines are stopping for 3 minutes all at the same time. And that simple insight, and it's a very simple insight, drove them to ask the question, why? Nobody informed, nobody reported the failure of the auto changeover. Now it was reported, they fixed it, and they were able to drive that many more machine minutes per day without any extra investments. So you can, these are simple use cases and these are simple things, but there are a variety of them. And what I would want to leave you with, because I'm towards the end of this, what I would want to leave you with is don't necessarily look and try to replicate a project that your neighbor, your friend, your customer, your supplier has done. They may have done and they may have succeeded with that because they were facing a particular problem. Look inwards, either identify a problem that you today have and you want to overcome or if you're not sure, then start in a place where you have a gut feel that you can get more out of your machines. Put in the technology to monitor your machines, look at the data. Build the culture in your organization for people to look at the data from different angles, and you will definitely find improvements in that. On an average, what we have seen, clients are improving their OEE by about 20+%. That means for every 5 machines that you have in your factory, you today have a 6th machine in there lying idle. So look at it differently, see how you can digitize. There's a lot of value to be made and a lot of value to be driven.
Thanks for the nice presentation.
Hi.
So in the manufacturing world, okay, when we are going for the digitization, we found one of the most obvious problem is that every company doesn't function in the same way. Despite they are doing a similar kind of product manufacturing, but the process of working is not same. So workflow remains a most critical area. In case my workflow itself is not optimized, even if we are going for the digitization, it might not help me. So measuring part comes later, but first, in case, let's say you have to do a digitization of a factory where there is a ways of working is happening for manufacturing, how your digitization will help them to identify the optimized way of manufacturing, not only measuring the output of it.
Right. So there are many, the point is very, very valid, right? Every company, the workflow will be different and need not be optimized. So just let's take the example. I used to run a sheet metal manufacturing industry. I'll take my example, right? I never had a single sort of a line flow. Mine was all batch processing because we had products from a few grams to about 1.5 kilos, right? So different size of products. We couldn't arrange the machines in a line to produce just one part. So we had to do batch-wise production. Is that the most optimum? No, it's not. But what digitization can help you do is to help you sequence your operations, right? Because I had to produce, say, 500 numbers in my first stage, operation 10, before I can move it to the next operation, I was not knowing what was actually happening. Was I doing it immediately? Was I getting it as close to ideal as possible? Or were my team producing 5,000, then moving 5,000, doing the next operation, and then the third? So you want to reduce your batch size to as small as possible to make it the quickest throughput, right? So this is some information that can come out for you.
But how I'll optimize, and how I'll know that which path is my most optimized?
Right, because you're monitoring the output and the wait times. A typical MES, a good MES with IoT connectivity will give you your work in progress inventory and your wait times between stations. So what is your average WIP between operations and what is the average time between operations? And once you're able to identify that, then the actual engineering of it to reduce is really with you, who's the expert in your product and your process. But this will help in throwing light onto where the wastages are. Your machines may be waiting for want of input parts. Your material may be waiting for want of machine. Both are not ideal situations for you. Where exactly do you stand today? Do you have enough data to know this? Probably not. I mean, you probably have it, but to collate it from different sources becomes difficult. Having a single source of truth, as we call, typical industry 4 solutions are, you say it's a single source of truth. Having a single source of truth with unbiased data acquisition, which is your machine connectivity, will give you your wait times either for the material for a machine or machine for a material.
Okay. Sir, you were discussing about saving milliseconds about the robot. There is a need to change the robot itself because the time constant, even after you give a command for the robot arm to move and pick up something and place it, could also change along with optimizing the path you were mentioning. So is there a need to replace with a new robot to achieve extra this one, which responds to these time constants?
I think that's a very good question, but I may not be the correct person to answer that for you because I don't come from the robotics and automation point of view. In this case study, which I shared, there was no need to replace the robo. All they did was change the feeding mechanism to where the component came to for the robo to pick up. By changing that point, I think not the orientation was still the same, but just by changing the pickup point for the robo, that is how they were able to save. So without any additional investment. In this case, there was no additional investment. Certain other cases, what you have raised could be a very valid use point where changing the response time of the system for the robo between command to actual action will probably have a big impact. But I wouldn't be the right person to comment on that.
Because after pick up and place, when it leaves that weight, there will be some vibrations which has to be stabilized before the next. So it will also take some time.
Yes.
For the robo arm to stabilize again.
Yes. So again, I'm coming back to the use case that I shared. The placement was the same. It was the chuck of the CNC turning center. The pick place had the weight, the geometry was all the same. The position was shifted. Okay. So that is how they were able to save time. Again, zero extra investment, but the value was just lying in changing the position of where they picked up from.
Optimizing the path.
Optimizing that, yes.
Thank you.
Thank you so much. Yes, we'll probably take one last question. Yeah.
Hello, sir. Thank
Hi.
you for the talk. It was pretty motivating. I wanted to ask, you've done the hard part of it, like digitizing the machines actually, but have you also tried automating the easier parts? That is, if a client comes to you and he tells, I have 10 machines, do you also tell him which machine to digitize? That's the first question. And the second part is, if you give the data to him, then why not automating the insight part of it? That, hey, you have like this problem going on and I see it from my data, you can figure it out.
Right, so all very valid. When we go in, we typically, see, we don't do the consulting part of it, right? So we, again, will not tell them which machines, but what from experience, after having digitized 200 plus factories, we say you either digitize all. That should be your end goal, because it's not about unlocking value today. What you unlock today will sustain you further, but there's several more things to do. But typically what we recommend is the technology is not going to be the bottleneck. The change management is going to be the bottleneck. Getting your people to process data in a very different way. Example, if I give you an OEE report every morning for yesterday's 3 shifts, the way you will process that and the actions you will recommend will be very different from if I were to send you instant notification saying your machine is idle for 5 minutes, the other line has stopped because of a quality defect, the operator has not come on time. The way you process instant information and the way you process a consolidated post-mortem information will be very different. Technology both being the same. So what we normally recommend to clients is pick the smallest control area. It could be one part of your factory. It could be one type of process in your factory. It could be one factory, right? Pick a controlled area where the team involved in that section or operations are constant, so that they can start adapting and adopting to all of this. Once that is proven, then you can extend it to different sections. So that is probably what I would give you your answer to question 1. On 2, yes, we already do that. So this software is also analyzing what is happening, what are the correlations. A temperature has gone out of control. It's beyond a certain limit. It can lead to a breakdown of your hydraulic pump or your machine. That alert and notification will go instantly to the users, and there's an escalation mechanism. So the software is also constantly monitoring all of these inputs to give real-time alerts and insights into what's happening.
Thank you.
Yeah, thank you. All right, thank you very. That brings me to the end of my presentation. Thank you.